Hello, good evening. And in this session, we're going to discuss how do I evaluate this integral. This integral looks very ordinary at the beginning. So because just you have to integrate from 0 to 1, then log of x square minus x plus 1 over x into log x. So here, what I'm going to do is I'm going to convert this integral to an elegant double integral and then find the corresponding solution. So you can also try by your usual methods. Okay. Now let's see. How do I do this? So integral 0 to 1 log of x square minus x plus 1. So if you look at this expression, so x square minus x plus 1, then this looks familiar because I could write this thing as x cubed plus 1 over x minus x cubed plus 1 over x plus 1. That's what we have because if you see here, so x cubed plus 1 is what? X plus 1 into x square minus x plus 1. So I'm just rewriting this thing. So in the step number 1, I'm going to write down 0 to 1 and then log of. This could be written as now further x cubed plus 1. And then using the property of log, I could write log of m over n is log of m minus n. This over x into log x dx. Now soon after this integral becomes a bit complex and it's a really cumbersome task to integrate this. So the ideal goal is what? If I see here, then I see that there is a pattern. So x power, this is some number. So here also I'm getting this just 1. So can we think of a function whose integration is this? So deep down, if I see here, so whose integration turns out to be log. So it should be appearing in the denominator. So it should be like this, x power y plus 1. And then here I have dy. So if I integrate this, that's going to be x power y. And then log also is required. So I'll just multiply and divide by log x. And that also I have here. So I'm blessed with log x also. So this part, if I see, then this turns out to be 1 over log x here. And then integration of this would be simply ln of x power y plus 1. Or it's better we'll use log only because the entire integration is in log. So I could write here log of x plus y. So now I just have to take care of the limits. So if I see here eventually, then what happens? This part, it's x cubed, so upper limit should be 3. And this is x plus 1, so lower limit should be 1. So here if I do this, then I'll be having here 1 over, this is log x into log of x power 3 plus 1 minus the lower limit will be log of x plus 1. So this is the whole idea. Now we're going to convert this thing integral 0 to 1. So I have 1 over x left. So I'll keep this 1 over x here itself and then write down the integral 1, 2, 3. And then this dark part, I could write here x power alpha over 1 plus x power alpha, no, not alpha, y we have taken. So I'll add on there y. So it will be dy, dy and then dx. And that's what we have. So now if we see here, then this turns out to be this integral 0 to 1 dy dx I have. So I'll just take this one inside. So I'll be having 0 to 1, 1, 2, 3. This will give me x power y minus 1 over 1 plus x power y and then dy dx. Now, since both the integrals are constant, so we can simply apply Fubini's theorem. So what we will do in that case, this part, what is Fubini's theorem first of all? So integral a to b, and then this is c to d, not just for constant, of course. And if I have here, so f of x, y, dy, dx, then this integral by the suitable transformation can be converted to f of x comma y itself, but then this will become dy over dx. So I could write here c here d, and then a to b. Okay. So just for simple understanding, if a, b, c, d are constants, if they are functions, then this converts the entire integration to something else. So I suggest the viewers to watch Fubini's theorem. Fubini. So now for that case, I'll be having here. Now, if I see here, then I could write here 0 to 1. Oh, no, 1, 2, 3 first. So for that case, I'll be writing here 1 to 3 first, and then 0 to 1. So for I'll be having x power y minus 1 over 1 plus x power y, and then I'll first integrate with x and then with y. So when I'm integrating with respect to x, then this is 1 plus x power y. So when I do this as 1 plus x power y, its derivative would be x power y minus 1, but then here y will come. So what I'll do, I'll multiply and divide by y. So y is now here, and then 1 upon y is here to balance it. Because when I'm integrating with respect to x, y is acting as constant. Here I played the reverse thing. So now for this purpose, I'm going to have here integral 1 to 3, 1 over y, and then this integration right here is nothing but now this is my function, and here I have the derivative. So I can just simply write down ln of, say log of x power y plus 1, and the limit is going from 0 to 1, and then dy. So remember, this integral was with respect to x. So now I have to plug in the limits of x here from 0 to 1. So 1, 2, 3. This integral will go from 1, 2, 3. 1 over y will be as it is. And then this will become log of, now plug in x, so this becomes log of 2. And when I plug in 0, so I get log 1, which is again 0. And then this is simply log 2 will be common, and then integration of 1, 2, 3, 1 over y dy, everyone knows. So this will become log 2, and then this is what? Log y, limit goes from 1 to 3. So this will be log 2 into upper limit will be log 3 minus lower limit is log 1, which is 0. So I hope this makes sense. You can use such concepts. And I'll be bringing some more problems similar to this substitution. Thank you so much for watching. Bye.